Today we're starting a series on sets and Venn diagrams. There's going to be several lessons to cover this. Today we're starting with language, the language of sets and Venn diagrams, mostly sets for today. So that just means what are the kinds of words that we use to talk about sets, and what are symbols and ways of writing things and saying things about sets. All right. First word, of course, is set. What do we mean by a set? A set is actually a collection of things, a collection of items. It could be all the students in my class. That would be a collection of students. It could be fish in a pond. All the fish in this pond are a set. They're a collection of items, or it could be the days of the week. Collection of items. A set, we can give a set a capital letter to mean set A. So if we're talking about a collection of the days of the week, if that was our set, and we would say we're going to call our set A. Set A consists of the days of the week. Well, I want to say not all the days of the week, but the days of the week that are work days, school days. Let's say school days. This is a description of my set. They're the days of the week that are school days. I could also list the items in my set and say set A is then Monday, Tuesday, Wednesday, Thursday, and Friday. Those are the days of the week that are school days. So this is my set A. I can describe my set by a sentence, a description, or just by listing the elements in my set. That brings me to another term that we use. We call these elements or members of the set. These 5 are the elements or members of my set A, which is this collection of days of the week that are school days. All right, another thing that we will often want to say about a set is how many items are in the set. So if we're looking at this set here, set A, we would say the number of items in set A, so you use parentheses and the N for the number of items in this set. Monday, Tuesday, Wednesday, Thursday, Friday, it's 5 elements, so we'd say the number of elements in A equals 5, right? Another symbol that we use would be this symbol, and this symbol. Let me use them correctly so that you can see what they mean. Wednesday is a member of set A. Saturday is not a member of set A, right? So this symbol means is a member of. This symbol means is not a member of, right? So Wednesday is a member of set A. That's true. Wednesday is inside of the set. Saturday is not a member of set A, right? Saturday is not a school day, so it's not included in the set. Okay, another symbol you might see is this symbol. This means an empty set. empty set that you can also write like this. So we get the squirrely brackets with nothing inside. Right? I forgot to point out the squirrely brackets. A set is always written inside squirrely brackets, right? Whether you list the elements or you give the description, it's always enclosed in these squirrely brackets. Here there's nothing inside the squirrely brackets, so it's an empty set. And I could give you an example of an empty set. Let's do one with days of the week again. Let's say we have a set B, and it consists of school days that start with the letter S. School days that start with the letter S. None of the school days start with the letter S, so B is an empty set. There is no elements inside it. All right. Then we have, I need a little more space. We have this symbol, which means the universal set. And it actually doesn't mean everything that you find in the entire universe, but it means all the elements that we're looking at, that we're considering in our problem or situation. So we could say if like A are the days of the week that are school days, we could say in that problem the universal set could be all the days of the week. Days of the week. So those are all the elements that we're looking at, and we're taking like a subset A, which is the days of the week that are school days, right? Talking about the same set A that we use there. So the way we could write that in a diagram would be like, say, this box represents the universal set. So all the days of the week in this problem, all the elements that we're looking at are the days of the week. We have Monday, Tuesday, Wednesday, Thursday, Friday. We have Saturday. Oops. Why do I write the whole word? Sunday. Inside this box are all the elements that we're considering. And now I'm going to circle my set A. This circle represents set A, which was the school days, right? The universal set was all the days of the week. Inside this big box are all the days of the week, universal set. Within that universal set, we have our set A, which consists of the days of the week that are school days, right? This diagram is called a Venn diagram, right? So, just an introduction. Now that we have learned all this language to talk about sets, we can do problems like this one, like these two. If we were asked to list the set factors of 10, list the set. So we want a list of the elements that are within this set. So we're going to just list all the factors of 10. 1 is a factor of 10, 2 is, 5 is, and 10 is, right? So this would be the answer to this question. How about describe this set by a rule? So we're given a list, right? And they want us to describe this list. Like, what are these numbers? 1, 3, 5, 7. So now we're going to describe it by a sentence. And these are obviously odd numbers. Positive odd numbers, yeah, positive odd numbers. And notice how here, positive odd numbers, that's not a limited number of elements, right? This list goes on and on, 9, 11, 13, 15, it goes on forever. And that's why we have these dots here. These dots mean this sequence just goes on and on and on, right? Here we have a limited set, factors of 10. There's only these 4. That's where it ends, right? So it's enclosed in the squirrely brackets and we have all the elements there. This means it's an infinite number of elements inside the set. Infinite in that direction, right? 1 is the first one, but this list just goes on and on. Dot, dot, dot. All right? Okay.